It was just about a month ago that the U.S. government finally admitted the existence of Area 51. Now, there's been a little bit of information about it. It's where they tested planes and so on and so forth, but it's also gotten another aura, if you will, an extraterrestrial aura. There are strong rumors and conspiracy theories and so on about the alien ship that allegedly landed near Roswell, New Mexico, being moved to Area 51 for reverse engineering. May or may not be true. Nobody really knows. But one of the fun things to think about is what goes on out there. And fortunately today we have somebody who could shed a little light on that. Ed, of course, is an associate professor at the University of Virginia in the Department of Astronomy. He teaches an introductory astronomy course to non-majors, which is like, that's good because I need to know how to say it. And evening classes and evening classes for the public in McCormick Observatory, which it looks like about a third of you have already taken, so that's great. His research interests are studying interstellar medium, which for those of us who don't know this sort of thing, it's the gaps in between things we can see. He uses an easy-to-remember satellite called the Far Ultraviolet Spectroscopic Explorer. And he also uses the big telescopes out in Green Bank, West Virginia. As a coordinator of education and public outreach for the Department of Astronomy, he runs the Public Night program and can be seen frequently in those events at the McCormick Observatory. As Althea already said, he produced with the teaching company Our Night Sky, which is a great learning program, and helps people understand what goes on out there. It's still a great mystery to us, and therefore a subject of intense fascination. Help me introduce or welcome Ed Murphy.
Thank you. Thank you very much. Thank you for coming this morning. It's also probably worth mentioning that I'm also a graduate of the University of Virginia. That makes me a bit unusual amongst the faculty. I happen to be a double who, so I have 2 degrees from UVA. So I thought what we will talk about today is this question that almost everyone has asked at some point looking up at the night sky. Are we alone? Is there extraterrestrial intelligence out there? And we'll talk a little bit today about an interesting question about the search for extraterrestrial intelligence, which is called the Fermi paradox. So I thought right away I'd start with an audience participation part of the thing. And I would just like to find out who believes that we are alone. So right now, if you believe that we are the only intelligent civilization in the Milky Way galaxy, raise your hand. If you think we are alone. Okay, I'm going to make everybody commit so you can put your hands down. Now, if you think we are not alone, that there must be somebody else out there, raise your hand. Okay, so we're going to have some interesting questions for those that think that we are not alone out there in a second. And my ultimate goal for this talk, I hope you didn't come hoping to get a definitive answer to this question, because you're not going to get one today, certainly not from me. But I do hope to give you some things to think about today, as you leave today, to think about this question of whether we are alone or not. But I'm going to take an aside for a second and talk about my interest in teaching this here at the university, and in particular a class that I'm teaching this semester called a College Advising Seminar. The way advising used to work in the College of Arts and Sciences is that faculty members, so first of all, you should know that at the University of Virginia, academic advising is still done by the faculty. Most other schools have now parsed this out to graduate students or hired advisors who see hundreds of students. At the University of Virginia, we still have the faculty in the College of Arts and Sciences. The faculty still do the advising. Every semester, we were assigned 20 students or so who would come to our office at the very beginning of their time at UVA, and we would talk to them about course selection. And then I would see them in October for picking classes for the spring, and in the spring for picking classes for the fall. And by the end of their second year, when they would declare a major and get an advisor in their major, I might see these students just a couple times and probably for 10 to 15 minutes apiece. And I wasn't happy with that particular system. I know a lot of the faculty weren't happy with that system. So the College of Arts and Sciences came up with a new course called a COLA seminar. COLA classes, COLA just stands for College Advising. And these are classes for first semester, first-year students. They're brand new to the University of Virginia, and they get a class, 18 students at a time, with a single faculty member who then becomes their academic advisor. So I get to spend with these students, instead of 10 minutes now and 10 minutes later on in the semester and 10 minutes next semester, I get to spend 75 minutes a week with these students talking about a topic that is interesting to them. And I know it's interesting to them because they picked this class out of the 47 different COLA seminars that are offered. So right away, we have something in common to talk about. This also solved another problem that we had at the University of Virginia, and that is that the first-year classes for first-year students, think about back when you took chemistry here at UVA, there's typically an auditorium with 400 students in that classroom, and the professor is literally this little tiny person down front. I've always been surprised how 2/3 of the way through the semester, I'm a bit taller than average, students would come down for the first time, and they would say, "Wow, you're taller than I thought." And that's because they were always in the back looking at me, and I just looked like this little person. So now they get to know me right away in this college advising seminar. So this class that I'm teaching this semester is on this question of, are we alone? And I think it's a great topic because regardless of whether they are scientists or interested in political science or interested in business or medicine, there's something in this question for everybody. The last thing I'll point out about the class, because it's kind of special this year, for those of you that aren't aware of this, for the first time in decades, we are now teaching in the rotunda again. And I'm lucky that this is the Lower West Oval Room, and I get to teach there this year. So people often ask, looking up at the night sky, seeing thousands upon thousands of stars up there in the night sky, as to whether we are alone or not in the universe. This is a picture taken by a place that's a couple hours northeast of Phoenix, Arizona, called Mount Graham. The University of Virginia operates a big telescope up there. We're a partner with a whole bunch of other universities that are operating this telescope, and this is what the sky is supposed to look like. Now, most of us have probably not seen, certainly not if we live here in Charlottesville or Northern Virginia or the Tidewater area, we have not seen skies that look like this because of all the light pollution. This is one of the best dark sky sites left in the continental United States, and we still have to deal with light pollution from Phoenix, Arizona right there, and that ugly yellow glow there. That's Tucson, Arizona down there. But this is what the night sky is supposed to look like. When you go out at night, you're supposed to see thousands of stars, and more importantly, cutting across the sky, you should see that milky band of light called the Milky Way galaxy. That's the galaxy that we live in, and that galaxy consists of a few 100 billion stars. Now, we've never been outside the galaxy. We won't be outside the galaxy, not in my lifetime or my children's lifetime or my great-great-grandchildren's lifetime, because the galaxy is so big. We'll talk about that in a second. But if we could get outside the galaxy, this is what our Milky Way galaxy would look like. Based on our best estimates, we think there's somewhere between 200 and 400 billion stars in the Milky Way galaxy. And again, that's what it would look like from the outside if we could look back at it. And for a long time, people have looked at the galaxy and looked at the number of stars in the Milky Way galaxy and wondered, could there be somebody else out there? Are we the only ones? Maybe the most famous scientist to do this is a gentleman by the name of Frank Drake. Frank Drake, in the early 1960s, held a conference in Greenbank, West Virginia, about the search for extraterrestrial intelligence and the question of whether we are alone or not. And he came up with a famous equation called the Drake equation, and I won't go through too much of the details because it is a football Sunday and you didn't come back for a math refresher. But it's a really interesting equation because it helps organize our thoughts about the question. And the gist of the equation goes something like this. Our galaxy contains, say, 200 billion stars. Imagine that 1 out of every 10 of those stars is like our sun. That means there are 20 billion sun-like stars. Now imagine 1 out of every 10 of those had an Earth-like planet. That means there are 2 billion Earth-like planets around sun-like stars in the Milky Way galaxy. Now imagine just 1 out of every 10 of those Earth-like planets managed to form life. Then there would be 200 million Earth-like planets around sun-like stars that have life on them. And then imagine that 1 out of every 10 of those formed an intelligent civilization there could be millions of intelligent civilizations out there. And if only 1 out of every 10 of those develop the ability to communicate or travel amongst the stars, there should be millions, hundreds of thousands, or millions of civilizations crossing the galaxy. So Drake put together this equation to describe exactly that. This is roughly, I won't go into the details of it, but roughly the number of stars, the fraction of stars that have planets going around them, the number of Earth-like planets, the fraction of those Earth-like planets that form life, the fraction that eventually form intelligent life, the fraction of those that eventually have the ability to communicate, and then an estimate for how long the civilization lasts, whether it lasts for a long time or just pops up and then disappears. Now, the problem with the Drake equation is we don't know most of these numbers to any degree of accuracy. We know the number of stars, or in the way that Frank Drake wrote it, the rate that stars form. We know that number pretty well. And for a long time, that was the only number that astronomers knew quite well. But since 1996, astronomers have figured out a way to find planets around other stars. And so right now, we have a pretty good idea of what the fraction of stars that have planets are. And it's at least 6%, maybe much higher than that. We are finding that planets around stars are in fact quite common. We don't yet have a good handle on how common Earth-like planets are, but I believe in the next decade, with all the new telescopes and observatories coming online that are working on this problem, that we'll get a good handle on the number of Earth-like planets. Beyond that, now we have to leave it up to the biologists to tell us how easy it is to form life, what fraction might form intelligent life, and what fraction of those might communicate. So because so many of these numbers are still uncertain, you can pick, based on reasoning, what your favorite number is. And so I'm going to show you just some scenarios here. So we have the optimistic optimist up here and the pessimistic pessimist and people in between. Don't worry about the numbers in here, but these are the important numbers up here. If you're really optimistic and you pick the most favorable chances, there could be 30 million intelligent communicating civilizations in our Milky Way galaxy. But that's the really optimistic estimate. If you're a little more pessimistic than that, you pick slightly lower numbers, you come up with about 25,000 intelligent civilizations in the galaxy. Somebody a bit more pessimistic than that believes it's a little bit harder to form life and civilizations don't last very long, they might come up with only 10 civilizations in the Milky Way galaxy. And the really pessimistic folks come up with essentially 1. We are the only intelligent civilization in the galaxy. And people are laughing because maybe not. Maybe it's less than 1. But I would argue it's an interesting question. You know, an interesting question is, how do you define an intelligent civilization, and how long have humans been intelligent? And for me, as a radio astronomer that's interested in this question, a civilization doesn't become intelligent until they have the ability to communicate between the stars. Because imagine the technology that we had in the year 1900. We would all argue that with steam engines and the beginning of electricity and automobiles and on the verge of flying, that we were an intelligent civilization. But we did not have the ability to broadcast off of our planet. Nobody knew that we were out there. So they're a completely undetectable civilization at that point. And so you really need to have radio telescopes and radar and the ability to communicate amongst the stars. And we have only had that here on Earth for about 70 years, since World War II. So we have only been an intelligent civilization that would be interesting to other intelligent civilizations in the sense that they could detect us for only 70 years. So that's a very small, could be a very small number. Now, there are a lot of stars in the Milky Way galaxy, but the galaxy is also a really big place. So this is the size of our galaxy. We estimate that it's 100,000 light years across. A light year is the distance that light travels in 1 year. It takes light just 1 second to cover 186,000 miles. That's 3/4 of the distance to the moon. And the length of time it takes you to say 1 second, light travels 186,000 miles. And yet to get from one side of the galaxy to the other side of the galaxy at 186,000 miles a second, it takes 100,000 years. Now, we don't live in the center of the galaxy. We don't live on the edge of the galaxy. We live about halfway out in the galaxy, about 26,000 light years from the center of the galaxy. I like to think of it as sort of the inner ring of suburbs of the galaxy. We're not downtown, and we're not out in the country, but we're We're in the inner middle part of the galaxy right there. But our galaxy is so big, you might ask the question, if we estimate how many civilizations are out there, where is the nearest civilization to us? And so for those scenarios I gave you just a second ago, imagine that there are 30 million civilizations in the Milky Way galaxy. If they're evenly spread throughout the galaxy, and we don't know that that's true because we don't even know that there's one out there beyond us, but if they're evenly spread throughout the galaxy, the nearest one is probably about 60 light years away from us. If there are only 25,000 intelligent civilizations, the nearest one is probably 700 light years away. With 10 civilizations, the nearest one is 9,000 light years away. And of course, if we are the only intelligent civilization in the galaxy, there's nobody else out there to communicate. So that's the distance. So even in the most optimistic, the most rosy scenario, the closest communicating civilization is likely to be about 60 light years away from us. And we'll see how that becomes important in a few minutes. The last thing I'll mention about our Milky Way galaxy is it's big. It has a lot of stars. And the other thing to know is that it is incredibly ancient by human standards. So it's 13.8 billion years since the Big Bang. The Big Bang happened 13.8 billion years ago. And we believe our Milky Way galaxy formed about 1 billion years after that, roughly about 13 billion years ago. Now, the problem with 13 billion years, it's such a large number that we all have a really hard time even comprehending what that is. So let me try and squeeze that 13.8 billion years into a length of time that we can all understand. And that length of time is a human year, a single year here on Earth. Imagine that we take 13.8 billion years and cram it into one Earth year. So the Big Bang happens on January 1st at midnight, and December 31st at midnight, the following December 31st, is right now. If we take those 13.8 billion years and cram them into a single calendar year, we come up with the fact that a month is a little over 1 billion years. It's about 1.2 billion years. A single day is about 38 million years, and a single hour is about 1.5 million years. So let's look at some events in the history of the calendar out here. So the Big Bang happens on January 1st at midnight. Sometime in early February, our Milky Way galaxy has finished forming. At this point, our Milky Way galaxy consists of hundreds of billions of stars. A typical star like our sun lives for 10 billion years, which is about 8 months on the calendar. Really massive stars, big hot blue stars that burn their fuel so fast, they usually live for about 2 million years, which is a little bit more than an hour, a single hour on this galactic year, this universe calendar. So lots of stars are born in the Milky Way. The stars are born, they live out their lives and die. New stars are born, live out their lives and die. New stars are born, live out their lives and die. And this continues on through May and June and July and August. And then finally, sometime in early September, around September 3rd, our sun, the Earth, and all the planets in our solar system form. So if the Big Bang is on January 1st, our planet doesn't come around until September 3rd. An amazing thing about the Earth is that just after it cools off, just after it becomes stable, life develops. The earliest life, the evidence that we have for the earliest life on Earth is around September 22nd. So it takes almost no time at all for at least simple life to occur on Earth. But then an interesting thing is that we get simple life on September 22nd, and that simple life exists all through the month of October, all through the month of November. And we don't get the first really complex animals on Earth until December 17th in an explosion called the Cambrian explosion. That's when we get all the complex life forms that we see today, all the animals that we see today show up in the Cambrian explosion. We have complex life forms until the day after Christmas, December 26th, the dinosaurs arise on the Earth. And remember, a single day is 38 million years, so the dinosaurs do great for themselves. They survive 5 whole days on this calendar. 1, 2, 3, 4, 5. The dinosaurs go extinct on December 30th. On December 31st, that's when all the interesting things that we think of as humans happen. On December 31st at around 9 o'clock in the evening, the first hominids arrive on the Earth. Modern humans evolve at 2 minutes before midnight. Agriculture comes along 25 seconds before midnight. The pyramids were built 11 seconds ago. Galileo and Kepler showed that the Earth is not the center of the universe, that the sun is the center of the solar system, all the planets are orbiting around it. That happened 1 second ago. A human lifetime of 80 years is 0.2 seconds on this calendar. And so your lifetime happened within the last 0.2 seconds or so before the calendar ends. So the point I wanted to make out of this is our galaxy is ancient. What makes us think that in this whole long history of the galaxy, where the Earth doesn't form till here, and intelligent humans don't form till here, and really intelligent humans that communicate don't form until the last tenth of a second before midnight, that we might be the first civilization ever? It seems like there's been lots of opportunities for stars to be born, live out their lives, and die, and have other intelligent civilizations out there. So our galaxy has a lot of stars. It's really big, and our galaxy is ancient. And all three of these arguments came together in a beautiful paradox put together by a famous physicist by the name of Enrico Fermi. Fermi was one of the scientists that worked on the U.S. atomic bomb. He was the first scientist to have a controlled nuclear chain reaction at the University of Chicago. And in the summer of 1950, Enrico Fermi was working at Los Alamos National Laboratory in New Mexico. And Fermi was out having lunch with his friends, and he was walking to lunch with his friends, a couple of colleagues, and they were talking about two interesting news stories that were in the news that summer. The first interesting news story was that there was a rash of UFO sightings. The other interesting news story was that trash cans were disappearing from New York City, and no one knew why. And the scientists got to talking, and one of them said, "Did you see that cartoon that appeared in the New Yorker?" And they talked about this cartoon that appeared in the New Yorker that very nicely solved both of these problems. And Enrico Fermi joked with his colleagues that, in fact, that's a very good hypothesis, because any idea in science that can explain two very different things is a really strong hypothesis, but he was just joking about it. So the conversation goes on from this, and the conversation goes on to whether it would ever be possible to travel faster than light, and whether that would come along in the next decade or the next 2 decades. And then they started moving on and talking about other things, and a few minutes later they're sitting down at lunch, and it gets quiet for a second, and Fermi looks at his colleagues and asks an incredibly important question. Fermi asks, "Where is everybody?" He realized, because he did the numbers in his head as they were walking to lunch and while they were sitting at lunch, that our galaxy has so many stars, and it seems like there should be so many intelligent civilizations out there, and our galaxy is so ancient that somebody should have come visited us by now. If you can travel at 10% the speed of light, it takes only 1 million years to cross the galaxy. 1 million years is a little more than a half hour on that calendar that I showed you a second ago. If an intelligent civilization were to arise, they can travel across the galaxy in half an hour on this calendar. Well, from the formation of the galaxy until we came along, there are an awful lot of half hours. There's been a lot of opportunity for an intelligent civilization to come find the planet that we live on and come settle here. And the reason that's important, of course, is that we live in a resource-rich solar system. If you can travel between the stars and you end up in our solar system, it has everything you could possibly want. It has metals, it has rocks, it has water, it has all the basic building blocks of life, it has the basic building blocks of technology. You would settle here. We would certainly settle here if we were off traveling the stars. Why didn't they? In all of the billions of years of our galaxy, why did they never come here and settle here? And you might argue, as we'll see in a minute, well, maybe they don't want to settle here because they know we're here. That might be true now, but 1 billion years ago, when it was nothing but little single-celled algae living in the ocean, I can't imagine that they were particularly concerned about the little single-celled algae out there in the ocean. So he asked this question, where is everybody? And it's now known as the Fermi paradox. If you raised your hand and you think that life is common in the galaxy, that we can't be the only ones out there, then you have to ask your question, why have they never come to visit us? Because they've had lots of time, they've had lots of opportunity, but they've never come here. So what we do in my COLA class this semester is we use a book by Stephen Webb called Where is Everybody? It's all about the Fermi paradox. And it explores possible solutions to the Fermi paradox. And the solutions fall into three categories. They fall into the "they are here" category. Maybe it's not a paradox, they're actually here. The second set of solutions are they are out there, but they cannot travel here, and they have not yet communicated with us. So we'll explore one of these ideas in a minute. And then the last one is maybe they just don't exist. Maybe we really are the only intelligent civilization in the galaxy, and maybe we're the first intelligent civilization in the galaxy. So I'm going to have to talk about the elephant in the room. Tom raised it a second ago. So, of course, we're not alone in the universe, right? We're being visited by UFOs. This is one of the solutions that Stephen Webb, and we spend a lot of time in class talking about this. They are here, and they are meddling in human affairs. So this is a very typical picture of a flying saucer, a UFO, an unidentified flying object. And the question is this the kind of evidence that we need to prove that we are being visited by an extraterrestrial intelligence? Is this enough? Scientists have tools to deal with this. I teach my students about these tools. A Scottish philosopher by the name of David Hume had a really good example where when you're faced with two things, you weigh the two of them and you have to reject the greater miracle, the thing that is less likely. I think Carl Sagan put it a lot simpler. He just said extraordinary claims require extraordinary evidence. And the question is, are these photographs that we see of UFOs, do they rise to the level of extraordinary evidence that's required to make the extraordinary claim that we're being visited by extraterrestrial civilizations? So here's another one right here. So the question is this good enough? Well, we can examine a couple examples. So these are ones taken by a gentleman by the name of Paul Villa. Both this photograph and that one were taken by Paul Villa. He was one of the most prolific photographers of UFOs. The reason is he had a telepathic connection, and they told him where he should go and when he should go there so that he could take pictures of them and publish them in the early 1960s. And he has published, it's produced dozens and dozens of photos of UFOs. Photos of UFOs, I think, are becoming more and more problematic. And in a sense of saying that it's getting harder and harder to believe that UFOs really exist. And let me give you what I think is a beautiful example of this. On November 7th, 2006, at Chicago O'Hare International Airport at 4:30 in the afternoon, 12 employees of United Airlines reported seeing a saucer-shaped object hovering over Concourse C at O'Hare Airport. They watched it for a few minutes because it was there long enough that they could go inside and get others. So a couple people saw it. They went inside. They got others so that in the end a dozen people saw it. And then at the end, the object accelerated quickly into the clouds and disappeared, and it left a hole up there in the sky. So the question is, what do you do with a report like this? These are all very reasonable people, right? We can laugh about Paul Villa and his telepathy being told where to pick up the UFOs, but these were pilots. These were baggage handlers, they were gate agents, they were flight attendants, they represented all areas of employment at United Airlines. People who, frankly, we put our lives in their hands when we get on their airplanes, and they thought they saw something enough that they reported it both to their airline and to the Federal Aviation Administration. So, is this evidence that we're being visited? I have a problem with this report, and the problem is this. Just out of curiosity, how many people in this room right now are carrying a camera with them? Think about your cell phone. If you don't think you're carrying a camera, think about your cell phone. So most of the audience is carrying a camera with them. If an alien walked in and walked up and stood right next to me, I would hope, well, Althea will get a picture. She's been taking pictures. But I'm hoping that besides Althea, a whole bunch of you will get your camera out and take a picture of it. The problem I have with this is O'Hare International Airport. It's a busy November day in the early evening. There are thousands of people outside at O'Hare Airport at that very minute. There are tens of thousands of people inside the concourses at O'Hare Airport. Thousands of people were there, and only 12 saw it, and nobody took a photo of it. Not a single photograph exists of it. And for me, that's a big problem. How could it be that thousands of people did not see this, and no one thought to take a picture of it? And I think a really good piece of evidence for this is that there is something else that very rarely happens, and it's very tragic. But when it happens, we often get photos of it, and those are airline disasters. Even during an airline disaster, people take a camera out and they snap a picture of what's going on. These things hardly ever happen. They don't happen nearly as often as UFO sightings. And yet, these are the best pictures we have of UFOs. So, if you see a UFO, take your camera out, take a good picture of it. That's the first rule. I think, by the way, that this is also a really interesting statement because this will spell, I hope, finally, after decades, the death knell of things like Bigfoot, the Loch Ness Monster. I mean, think about how many people visit Loch Ness every year. How is it that thousands of people visit Loch Ness with thousands of cameras every year and nobody gets a good picture, right? The one picture we have is this blurry animal out there in the water. I find that hard to believe when even rare events are captured clearly on photography today. What did they see at O'Hare? I have no idea what they saw. I wasn't there. My guess is it's something like this. These are called lenticular or lens-shaped clouds. They have nothing at all to do with UFOs. They're very common phenomena. They often occur over mountains, but they don't have to. Sometimes they occur in isolation by themselves. Maybe they saw something like this. I don't know. As a scientist, I can't explain what they saw, but I don't believe that what they saw was an extraterrestrial civilization visiting us. We can ask this question: if a real object appeared in the sky above a modern metropolitan area, what would happen? And we had a beautiful example of that in February of this year. On February 15th of this year, an object appeared in the sky above the city of Chelyabinsk in southwestern Russia. And it was photographed by dozens of people from different vantage points using different cameras. This is what happens when something real appears in the sky. It is seen by thousands of people, and it's photographed by hundreds more. This is the kind of evidence I think we have to demand. For people that believe that we're being visited by UFOs, this is what we need to see. We need to see dozens of photographs from different people who all saw something in the sky and saw something clearly in the sky. So I don't have time to go over all the other photographic evidence. One of the things we do have to worry about these days is Photoshop, because a number of people have put photos out there that have been Photoshopped claiming they've seen UFOs. But I know what you're asking. You're thinking to yourself, Tom mentioned Area 51 a few minutes ago. Well, of course we've been visited by aliens because we have one of their spaceships in June of 1947, didn't a spaceship crash in Roswell, New Mexico? And the U.S. government secreted away the spaceship and buried the dead aliens and kept some of them for autopsies. This has been investigated at length, both by the U.S. Air Force, by scientists, by others, and it seems to me to be quite clear that the first thing that happened was when this event happened early on, the Air Force made a terrible mistake in trying to cover up what was really going on. This is the only evidence that we have of the spaceship that landed. This is the Mac Brazel owned a ranch. These are photographs taken from inside his ranch house of the pieces that are left over from this purported UFO that crashed in June of 1947. What we know today is that the U.S. Air Force was testing at the time a balloon project. Well, actually, it was the Army Air Force. The U.S. Air Force didn't exist at the time, but it was the U.S. Army Air Force was testing a balloon project at the time called Project Mogul. The Soviet Union was on the verge of testing an atomic weapon. And the question was, if the Soviets tested an atomic weapon in the middle of their country, how would we know? Because we couldn't get within 1,000 miles of it. And the answer was, you float balloons over the Soviet Union. And these balloons carry radiation detectors, they carry very sensitive microphones, they carry other equipment to detect when a nuclear explosion goes off. They would launch these balloons over Europe, they would float over Russia, and then they would be retrieved when they'd fall in the Pacific Ocean on the other side. And the data that came out of them could be used to determine whether the Russians were setting off nuclear weapons. They were testing these balloons. And of course, this was a super secret project because they did not want the Soviets to know that we were going to be floating balloons over their territory. So they were testing these balloon projects in southern New Mexico. And on the bottom of the balloon, for testing purposes, was a giant radar reflector. And that radar reflector was made out of sticks of wood and mylar film. And when I look at that picture right there, that looks to me like sticks of wood and mylar, that sort of plastic film that we make balloons out of today that has a thin coating of aluminum on it that's a really good radar reflector. The Air Force has looked into this, and they believe that the crashes that people reported in June of 1947 near Roswell, New Mexico, were in fact one of these balloons that they were testing had crashed. A junior Air Force officer, concerned that the secret might get out, made up a cover story, and unfortunately the cover story he made up was that it was in fact a UFO, because UFOs were in the news. And that's where the headlines come from. The Roswell Army Airfield captures a flying saucer over ranch in Roswell region. So he creates this cover story, which I think is very unfortunate because we're still dealing with that almost 70 years later. But in any case, I think it's a high degree of certainty that that's what crashed in Roswell, New Mexico. And I think everyone, serious scientists who've looked at this data have all come to this conclusion that the Air Force is telling us the truth now because this program is no longer classified, and so they can tell us the details. Now, you might ask, well, didn't they get aliens out of this spaceship, and didn't they perform an autopsy on it? I saw that on the Fox TV network in 1995. And the answer is yes. A film producer in London by the name of Ray Santilli said that he got film from somebody who was there in 1947 and filmed the autopsy as it was happening. And Ray Santilli produced a TV program for the Fox network about this alien autopsy. Now, they did a good job in some senses. The instruments that the doctor uses in performing the autopsy are in fact authentic instruments that would have been used in 1947. The clock on the wall looks like a clock that they would have had in 1947. The phone on the wall, which is visible in some scenes, you can see the cord hanging down there, is the cord that they would have had in 1947. So they did a good job on some things. They did not do a good job on other things. So one of the problems that they have is that the pathologist, the prosecutor that's doing the autopsy, uses the scissors in a way that you and I would use a pair of scissors. When I cut with a pair of scissors, I use my thumb and my forefinger, but that's not how doctors are taught. Doctors use their thumb and their middle finger so that they can use their forefinger to steady the blade as they cut. And the person using the scissors was clearly not trained in the techniques of an autopsy. They make the cuts in the body much too gingerly, not like a real pathologist would do. And there are a number of other errors in this movie. So that made scientists doubt that this was real. From 1995 until 2006, Ray Santilli maintained that this video was real. But in 2006, a couple things happened. Some people investigating it found the special effects crew that produced the dummies. They even talked to the butcher at the local meat shop that sold them the entrails that they had stuffed inside the body so that when they were doing the autopsy, it would look like they were pulling organs out. And so in 2006, Ray Santilli was forced to admit that the video was a hoax. Now, he still claims that somebody brought him a video of an autopsy of an alien done after the Roswell crash. But the video, the old film, was in such bad shape that he couldn't use it. And so he had to recreate it in the studio. But that he actually did see a film like that. And in my opinion, after maintaining that this was the authentic thing for 11 years and only then admitting that it was all fake, he's lost all credibility in my mind. So I don't believe that we have captured aliens either. So I don't believe that they are here visiting us. Now, maybe they're visiting us, but they just don't want us to know that they're here. A famous hypothesis put forward by John Bell in 1973 is called the zoo hypothesis. Maybe they've set us aside in an area which we live in like a zoo. And they have designed it so that they don't want to be found, and they have the technological ability to make sure that we can't tell that they're out there. So for those of you that grew up watching science fiction in the 1960s, you'll recognize this from Star Trek, right? This is the Prime Directive, General Order Number 1 for Starfleet, which says it forbids the interference in the internal affairs of less technologically advanced civilizations. There's a couple problems, in my opinion, with the zoo hypothesis. The first one is, how well did it work for Star Trek, right? It didn't work at all. Those of you who are Star Trek fans will remember that whenever Captain Kirk arrived on a planet that had the Prime Directive, almost the first thing he did was throw it out and interfered with the civilization anyhow, because it wouldn't be a very interesting television show if he just said, well, we have to leave them alone, let's go to the next one. But that aside, it is true that if you have an embargo that prevents intelligent civilizations from visiting us, they all have to agree to the embargo. That is, It only takes one civilization to break the embargo to let us know that they're out there. It only takes one civilization to break the embargo accidentally to let us know that we're out there. The other problem, in my opinion, with the zoo hypothesis is it's really hard to keep the animals in the zoo. Because unlike the zoo at up, say, in Washington, where the animals are confined inside of a cage, the Milky Way galaxy is rotating. And the galaxy rotates at different rates. The inner part of the galaxy rotates faster than the outer part of the galaxy. So imagine you set up a zoo around the Earth, and they're not allowed to come visit us. Over time, as the galaxy rotates, the zookeepers get pulled away from us. The ones closer to the galaxy go around faster. The ones further out go around slower. The zookeepers can't keep up with us because the galaxy is rotating. That's another problem with the zoo hypothesis. But my biggest problem with the zoo hypothesis is this final statement. They do not want to be found, and they have the technological ability to ensure this. That means it's not testable by science. If you come to me and you say, well, they're out there, but they're so good, there's nothing we can do to detect them. None of your scientific instruments can detect them, then to me as a scientist, it's an uninteresting question. If I can't test it, if I can't use my instruments to test this idea, then it's not a scientific theory. Or a scientific hypothesis, I should say, in this case. So that's another one of the interesting ideas that have come up. Maybe they're not visiting us because space flight amongst the stars is very difficult. And this one, I believe, is quite true. So this is a picture of Voyager 1. It's a cartoon, obviously, because we don't have any pictures of Voyager 1 in space. But Voyager 1 is the most distant spacecraft we've ever launched. It was launched on September 5th in 1977, so this past Thursday. It celebrated its 36th anniversary in space. We're still talking to Voyager 1. We talk to it on a monthly basis. We send signals out to Voyager 1. Voyager responds and sends its signals back. To give you an idea of how far Voyager 1 is away from us, remember that light travels 186,000 miles per second. Voyager 1 is about 17 light hours away from us. That is, when we send it a signal, it takes 17 hours traveling at the speed of light to get out to Voyager 1. Voyager 1 hears our signal, it responds. It takes 17 hours for its response to come back. The round-trip time to Voyager 1 and back, after 36 years of travel, is about 34 hours round-trip travel time. By comparison, by the way, the sun is only 8 minutes away, and Pluto is only 5.5 hours away from us. So this thing is more than 3 times as far as Pluto out there in the solar system. It's the most distant spacecraft we've launched. That said, after 36 years, it's now 17 light hours away from us. The nearest star, the closest star to us, is 4.5 light years away from us. So to get to the nearest star is 4.5 years. To get to Voyager 1 is only 17 hours. At the rate that Voyager 1 is traveling right now, it's going to take 75,000 years to get to the nearest star. So in my lifetime, we will not travel to even the nearest star. In our children's lifetime, we will not travel to the nearest star. And even, as I said earlier, in our great-great-great-grandchildren's lifetimes, we're not likely to travel to the nearest star because the distances between the stars are so vast that it takes long periods of time. So just to give you an idea of how long this is, the fastest spacecraft that humans have ever built, ever launched, travels about 30 kilometers per second. 30 kilometers per second is 0.01% the speed of light, or there it is as a true fraction, 0.001 times the speed of light. At the rate of the fastest spacecraft we've ever built, it'll take 44,000 years to get to the nearest stars. Now imagine that our grandchildren say that, well, my grandparents were old and slow. We're going to do something better than that. We're going to build one that goes 100 times faster. Now, that's a huge leap in technology because something you should know about the space program is from the very beginning of the space program until today, this number has not gotten any better. And that's because we're primarily using chemical rockets. And from the very beginning of the space age, we had pretty much maxed out the efficiency of chemical rockets. And we can't go much faster than this using chemical rockets. So they'll have to come up with a whole new technology. But imagine they come up with a technology that doesn't just go 10 times faster, it goes 100 times faster. It's still going to take their spacecraft 440 years to get to the nearest star. And remember, even in that optimistic, rosy scenario with 30 million intelligent civilizations, the nearest star isn't 4.5 light years away. I'm sorry, the nearest intelligent civilization is not 4.5 years away. It's 60 light years away. It's 15 times further than this. Now imagine that their great-grandchildren do a factor of 10 better than that, so that they can travel at 30,000 kilometers per second. That's 10% the speed of light. It still takes 44 years to get to the nearest star. It's not until you can travel at the speed of light that the travel time becomes something that we might consider remotely reasonable. Now here's the other problem. If we want to travel to the stars, it's going to take a very long time. And you're not going to do it in the kind of spacecraft we have today. Because even the best spacecraft we have today, for example, the space shuttle when it was flying, the space shuttle could house 7 people, but the interior volume of the space shuttle was about the size of 2 minivans. So imagine spending 44 years in 2 minivans with 6 of your best friends. It's not going to be a very pleasant trip. If I were going to take a long trip, something that was going to take me 44 years traveling 10% the speed of light, I'd probably want to do it a little more comfortably than that. Probably do it something like this. So imagine that you and say a few hundred of your friends are going to build a ship. Now it doesn't have to be, obviously a cruise ship has a very specific design, a very specific purpose for floating on the water. But I could argue that if you're going to commit yourself to spending the rest of your life on a spacecraft traveling somewhere, that you're not going to do it in the minivans, that you're going to want at least this much space. Besides the fact that you have to bring with you all of your food, all of your oxygen, all of the supplies that you're going to need to survive. So it's probably going to be very sparse living inside because you'll have large cargo containers of food and water and oxygen and everything else. But anyhow, we can imagine sending a ship of this size with a few hundred people and where they decide that they're going to leave the Earth and head off and say at 1% the speed of light, take 440 years to get there. That's an amazing thing because they realize the day they set out that they're not going to get to their destination and that their children aren't going to get to the destination and their grandchildren won't get there. They are committing every future generation to spending their lives on this ship, spending 440 years traveling across the stars just to get to the nearest star. I can't imagine there are a lot of people that would do that. Actually, I would have said that 6 months ago, but some of you are probably familiar with this Mars One project, which is a one-way trip to Mars, and they've gotten thousands of people to sign up for a one-way trip to Mars. But so I'm sure we would get some people to sign up for it. But in any case, sending them won't be easy. The energy that's required to accelerate this ship to 1% the speed of light is equivalent to all of the energy, all of the oil, gas, coal, geothermal, solar, all of the energy used in the United States in 4.5 years. Imagine taking all the energy that our whole country uses for 4.5 years and trying to condense all that energy into a single ship to accelerate it to 1% the speed of light so that it would still take 440 years to get to the nearest star. This is not a technological problem that we're going to solve anytime soon. And in fact, I would argue that this is such an intractable problem. It may be that they're not visiting us because no one in the history of the galaxy has ever figured out how to solve this problem. The distances between the stars are vast. The energy requirements are huge. And you're just not going to find anybody who's willing to do this, to travel across the stars like that. So people have thought of ideas, nuclear-powered spacecraft. People have even thought of giant colonies. Maybe we build huge space stations like this that aren't just the size of a cruise ship, but are large enough that people could live their whole lives here. Very much like we live our lives. You could have a small farm and grow your own food. But this is well beyond the technology that we have today. And I would argue, based on the Fermi paradox, that maybe no one has ever done this in the history of the galaxy just because it's so hard. Well, that still doesn't answer the question, why haven't we heard from them? Maybe they're not visiting us because it's so hard, but communication is something that's a lot easier. And so some of the solutions we explore in my COLA class are, maybe they're signaling us, but we don't know how to listen to them, or maybe they're signaling and we don't know at which frequency, which channel in the spectrum to listen at. Maybe our search strategy is wrong, or we've already got their signal, we just haven't recognized it yet, or maybe we haven't listened long enough. The problem with communication with extraterrestrial civilizations is that there are so many ways they could communicate with us that we don't know what to look for. That is, if you think about your radio or your television, the reason your radio and television work is that the engineers who designed the broadcast, designed the transmitter, talked to the engineers who designed your television. The designers of the television know exactly what channel it's being broadcast on, exactly how it's being broadcast, so they can design the television to listen to the transmitter. We have no idea how they might design their transmitter. We don't know whether they would try and communicate with us with radio waves or with visible light or even with something like gamma rays or X-rays. There's this whole spectrum of light that's available for communication. The advantage to using this light is that it travels at the speed of light. And the speed of light is the fastest speed there is. And so we can be quite confident that if they're using this, it's the fastest thing out there, but we just don't know where to look. It's in fact the classic question of a needle in a haystack. And I'll show you that in just a second about how hard it would be to find their signal. Now, astronomers on Earth have built giant radio telescopes, like the Very Large Array in Socorro, New Mexico. You may not know that the headquarters for the National Radio Astronomy Observatory that runs all of the nation's radio telescopes is right here in Charlottesville. They're right over by the astronomy department at UVA. The thing about this radio telescope is, as I'll describe in a minute, it's not actually used for searching for extraterrestrial intelligence, contrary to what you saw in the movie Contact. So in the movie Contact with Jodie Foster, she uses the Very Large Array for searching for extraterrestrial broadcasts, but that's not in fact how we use these arrays. These arrays are used for studying objects in space that emit radio waves. Black holes emit radio waves. The gas between the stars emits radio waves. Galaxies emit radio waves. And we do not use it for the search for extraterrestrial intelligence, but for the movie, it made a really nice backdrop. The other thing to know, and this is the more important one to know, is that these things pick up radio waves. They do not pick up sound waves. And so Jodie Foster sat there listening to a set of headphones. It was very dramatic in the movie as she sits there listening to these radio waves. The thing is, radio waves to you and me, their frequency is so high that even if we converted the radio waves into sound waves, we couldn't hear them. And even if you converted them into what we could hear, they would just sound like static. So this, again, was done for dramatic effect. Radio astronomers do not sit around with headphones on listening to their telescopes. We actually process everything through computers. So that's not how it's done either. But we're not using these antennas for searching. And in part, we're not using them for searching because of the classic needle in a haystack problem. These are all the things that when you pick up your television signal, the electrical engineers have agreed with one another about what channel you'll use, where the transmitter is. All these things have been decided by the engineers. The problem is we don't know what the aliens have picked for this. So we just have to search everywhere, and that's a big problem. So for example, direction in the sky. We don't know where to look. Depth of the signal. We don't know how strong or weak their signal is. We don't know how long we need to stare at a given spot in the sky to determine if their signal is there. We don't know what channel they're using on the spectrum. We don't know how wide their signal is. We don't know how they've encoded the information in their signal. We don't know when they've turned their transmitter on and off. Maybe their transmitter comes on every other Tuesday, and we don't know that. So if we're looking every other Wednesday, we're just going to miss them altogether. And you know, that's kind of funny, but if you think about the Earth for a second, the Earth rotates. And as the Earth rotates, our transmitters, seen from a distant star, only come on for 12 hours a day, because for the other 12 hours, the transmitter's on the far side of the Earth. So we don't know when they turn their transmitters on and off. Now, in Green Bank, West Virginia, there's a large series of radio telescopes. This is the Green Bank telescope. It's the largest fully steerable radio telescope in the world. To give you an idea of how big this is, it's 110 meters by 100 meters across. That's 330 by 360 feet across. Today's a good day to say this. If you want to imagine how big that is, that's the size, the football field at Scott Stadium would easily fit inside this dish, as would all the really expensive seats. So that's the size of this dish. It's open to the public. You're welcome to go there and see it. But to give you an idea of how hard this search would be, in order to use this telescope to search for extraterrestrial intelligence, there are the telescope looks at a tiny little patch of the sky. In order to cover the whole sky, we would have to point it in 3 million different directions. Now, the signal is likely to be very weak, so we might need to spend 10 minutes staring at each location in the sky, so that would mean 30 million minutes of searching. We don't know what frequency they're broadcasting at. We have an idea of where they might broadcast because we've picked up radio waves from objects in space, and it's likely if they want to be found They'll make it easy to be found. So they'll broadcast in those places where other objects in space broadcast, but that still means that there are billions of potential channels that we can look at. So there are billions of channels over millions of directions, and we don't know how long we need to stare at them, and we still haven't answered all these other questions. To do a deep search for extraterrestrial intelligence with a telescope like this would take thousands of years. And so for that reason, astronomers, radio astronomers like myself, believe that searches like this are probably not productive. This telescope costs $75 million. If you give it to radio astronomers, we can use it to make discoveries. We can use it to learn more about the universe. If we spent our time searching for extraterrestrial intelligence with this telescope, I can almost guarantee that after decades of using it, the answer would be, we still don't know. So for that reason, we're not using our resources to search for extraterrestrial intelligence. All these radio telescopes that you see, this one that you see, are not using their time to search for broadcasts because the odds of finding it are so small. In fact, the only really dedicated telescope that's out there right now, this is what it would take, by the way. Let me do this first, and then I'll talk about the one that's actually out there. In 1973, NASA did a study of what it would take to actually detect an Earth-like planet across the other side of the galaxy using radio telescopes, and they came up with Project Cyclops. Project Cyclops was a total of 1,000 antennas. Each antenna is the same size as this one. So it's 1,000 dishes that are each 100 meters across that all work in concert, all pointing in the same direction to try and pick up very weak signals. And then it would still take decades to survey the whole sky. Of course, Cyclops was never funded because each one of these antennas is $75 million, and you would need 1,000 of them, $75 billion to build an array like that. And there's just not that kind of funding. In fact, the only telescope array right now that is dedicated to searching for extraterrestrial intelligence is a privately funded telescope. It's run by the SETI Institute and the University of California, Berkeley, and it's called the Allen Telescope Array, and it was funded by Paul Allen, one of the founders of Microsoft. He was interested not so much in the search for extraterrestrial intelligence, but the amazing signal processing that has to go into this, and so he funded the development of antennas, an array of antennas, and right now they have enough funding that they have completed 42 of these antennas. What they would eventually like is an array of 350 of these antennas to search for extraterrestrial intelligence. Unfortunately, because it's a privately funded enterprise, this group has on a number of occasions run out of money, and in fact the array shut down in 2011 for about 9 months because they had run out of money. But this is the only array that's being used right now in the search for extraterrestrial intelligence, and it's a privately funded affair. Some other things to think about. Maybe everyone out there in the universe is listening, but no one's broadcasting. Transmitting could be dangerous. Some of you might remember the famous physicist Stephen Hawking said a few years ago that transmitting could be dangerous because the people who pick up your signal are likely very technologically advanced, ahead of you in terms of technology, and that when they show up on your doorstep, you will not in any way be prepared for the people who come to dinner. So it could be dangerous to broadcast, and maybe nobody does that. The thing is, here, we've already let the cat out of the bag. We have been broadcasting radar and radio and television for the last 70 years. Whether we want to or not, we have been sending radio signals off this planet, and they've now reached out to a distance of 70 light years away. And that, again, comes from our radar and our television broadcasts. And we're not intentionally sending signals out. We've only done it a couple times, but we are accidentally sending stuff out. I think the interesting statement about that is we've only had this technology for 70 years. Remember that in the most optimistic scenario with 30 million civilizations in the galaxy, the nearest one is likely 60 light years away. So even in the most optimistic scenario, they only probably picked up our first broadcasts a few years ago. And even if they responded to us, it's going to take 60 years for their response to come back. So maybe it's not surprising that we haven't heard from anybody yet. In fact, this was the very first message that we ever broadcast using the giant radio telescope in Arecibo, Puerto Rico. We sent a little pictogram, and there's a picture of a human. There's the double helix of DNA in there, some numbers, some shapes of atoms to let them know that we do know something about atomic physics, a picture of the radio telescope. But we broadcast this towards a cluster of stars that's 25,000 light years away. So if there's anybody in that cluster, they'll hear our signal 25,000 years from now. If they respond, we'll get the response 25,000 years after that. A depressing thing to think about is maybe intelligent civilizations are common, but before they can travel amongst the stars, before they can communicate with one another, they end up destroying themselves. Because once you have the technology to build radio telescopes, you have the technology to destroy your planet. Whether it's nuclear war, overpopulation, overuse of resources, global warming, biological warfare, chemical warfare, any of these things, we now have the ability to wipe humanity off the face of the earth. And maybe it's inevitable that intelligent civilizations who develop the ability to communicate amongst the stars also develop nuclear weapons or end up ruining the environment of their planet and killing themselves off before they can communicate or talk to us. I'm going to skip over this one for a second. So the last one I'll talk about is the rare earth hypothesis, this idea that maybe we live in a really special place. Maybe the reason that intelligent life is rare out there is because planets like the Earth are rare. And that could be because planetary systems are dangerous. Maybe there's something unique about the Earth. Plate tectonics, for example. Of all the planets in our solar system, the Earth is the only planet that has a major system of plate tectonics. And that has been very important to the development and evolution of life on this planet. Even Venus, which is a near twin in terms of size to the Earth, does not have the plate tectonics that we have. Our moon could be very unique. Our moon is a much larger moon than most moons in the solar system. It's about the quarter of the size of our planet. Some people have called the Earth moon not the Earth-moon system, but in fact a double planet. The moon could be very important to the Earth because it stabilizes the rotation of the Earth. It keeps our Earth's axis from tilting way over, which would cause crazy seasons on the Earth and may make it difficult for intelligent life to develop. It also provides tides on the Earth, and tides may have been important for the early development of life on Earth. Maybe it turns out that the origin of life itself is just a really rare event. We don't know yet how life formed on Earth. We have some really good ideas that scientists are working on about how life came about, but we just don't know how common it is. And even if you get life, maybe they don't come to the level of intelligence that humans have, or maybe you get human-like creatures, but they don't develop language like we did, which is necessary for passing on information. So the last hypothesis that we spend a lot of time in my class talking about is this rare Earth hypothesis. Maybe there's something really special about the Earth. Maybe we are the only intelligent civilization in the galaxy. It's possible that out of the hundreds of billions of stars, we're not the only one. Maybe we're the very first one that's out there. So I'll leave you with this thought. I'll come back to the thought in a second. The last thing I wanted to point out is one cool thing that our students are getting to do at UVA this semester is we've just become a partner with North Carolina, University of North Carolina, Chapel Hill, and a bunch of telescopes that they operate down in Chile. And our students this semester will be given access to these telescopes. They will actually be sitting in their dorm rooms at UVA, running telescopes down in Chile, taking pictures. There's one of the telescopes down there in the Atacama Desert. And the students in my class, the task that I have set them this semester is they're going to use these telescopes to try and figure out something about the search for life beyond Earth. They're going to carry out their own search for extraterrestrial intelligence with the telescopes that they have access to. Because in addition to these, there's a 60-foot radio dish, a 20-meter telescope in Greenbank, West Virginia, that they have access to as part of this. So in the 21st century now, our students here in Charlottesville will be running telescopes around the world over the internet doing their own search. So let me leave you with this thought. It comes from the movie Contact with Carl Sagan. If it's just us, it seems like an awful waste of space. Thank you.
Okay, we have a couple minutes for questions, so if you could just raise your hand, I'll walk this over to you, try to get you in order.
Has there been any explanation for crop circles?
Yes. So there are two gentlemen in particular that were responsible for a large number of the early crop circles, and they have admitted to this. They call themselves circle makers. So if you go out and do a search on circle makers, you'll find the two gentlemen that did this early on. And then after that, it became very much a prank. Lots of other people picked up on this. So we've got, and for the people to know that a number of people claim to be experts on looking at crop circles and claiming that they came from UFOs, and they themselves have been tricked many times where they've had these circle makers go out and make a crop circle. One of these supposed experts shows up and says this is clearly made by UFOs, and then only to find out that no, in fact, we made it last night with literally the way they make crop circles is with a board and a piece of wood, and they just go down and they push the wheat down, they push the crops down as they go. But look up circle makers. You'll find there's a whole society of people who hoax these crop circles. Yes?
Hi. On this notion of traveling at, say, 1% or 10% of the speed of light, even if you found the energy, it seems to me you're going to have a problem with running into grains of sand, because at that speed, even a grain of sand is going to really do some serious damage to your spacecraft.
That's right. Yeah, the energy of something goes as the speed squared. So even if you run into it, right now, if you run into a grain of sand in space, it can do serious damage to a spacecraft, maybe something a little bigger than a grain of sand. When you're traveling at 1% the speed of light, which is thousands of times faster than we're traveling today, the energy goes as thousands squared. So it's millions of times more energy. I think a funny thing about that is in the 1950s, people talked about shooting down UFOs, that there were reports that the U.S. government shot down UFOs. They've traveled across space. Little tiny grains of sand carry millions of times of energy of one of our little simple chemical rockets. How could we possibly shoot them down with one of our simple chemical rockets when they've had to deal with far, far worse getting here? But that's another problem they have to solve.
Okay, Ed, we've got one more back here.
Brilliant talk. I wish I could take your class. Life on Earth, at least most of it, is based on DNA.
Yes.
And it's the mutation of DNA with natural selection, helped along by sexual reproduction, that accounts for the evolution that has produced life as we know it today. The point is, if we could go back to the beginning and run evolution all over again, we would not end up with you and me. The result would be different. So if the chance of you and me happening once is so remote, the chance of us happening twice is remote squared, no matter how many thousands of possibilities exist out there. So the question then becomes, what sort of life are we talking about? It seems unlikely to be the kind of life that would understand a gold-plated CD containing music of Chuck Berry and a message by Jimmy Carter. Is it DNA-based life that we think might exist out there?
The answer to that is we have no idea.
So the question comes down to the one you talked about with communication. How would we recognize this life when we came across it?
Yeah, so what we would recognize is if they, regardless of what they're built of or how they're made, if they can build radio telescopes and send signals and we can talk to them, then they become an interesting extraterrestrial civilization because there's some hope that we would learn that they're there. So, but until they build radio telescopes, there's no hope that we could possibly determine that. But you raise a really interesting question, which is it's not just evolution, but there were unique events on Earth. A really good example being the large impact of an asteroid or comet that wiped out the dinosaurs, and the timing of that and possibly wiping out the dinosaurs and allowing mammals to take over the Earth. What if the timing of that were different? There could still very well be dinosaurs on the Earth today, and our ancestors, or we would still be small furry animals eating nuts off of the ground rather than evolving to who we are today. So it could be that the development of intelligence is extraordinarily rare in the galaxy. We just don't know.
Okay, we've got one more back here.
What's your opinion on the ancient visitors theory that they were here and left and they helped with the pyramids, they helped with Stonehenge, they helped the Mayans?
So my opinion on that is that the people who built the pyramids, the people who built Stonehenge, were every bit as intelligent and clever as we are. The human intelligence has not significantly increased since the time that the pyramids were built or Stonehenge was built. And so they were just as clever as we are, and they figured out a way to do it. Now, we don't know how they did it. That doesn't mean that they didn't do it. You can go online and you can find lots of interesting videos about how they might have built Stonehenge and how they might have moved those rocks. But I don't doubt that we don't have to resort to aliens doing that. When we do that, we're giving our ancestors, we're not giving them the credit for the fact that they were just as smart as we were. So, well, I'm afraid that's all the questions we can take. I'm happy to stay and answer questions afterwards. So if you'd like to come up, you can come on up. But thank you.